obtuse or straight. So pi, if you look at the unit circle, starts here at 0, and then because the radius is 1, this coordinate's actually going to be 1, 0, and then over here it would be negative 1, 0, and we're going around. So 2 pi r is the radius. The radius is 1, so it's 2 pi all the way around the circle. So I start at 0, I go all the way around to 2 pi. That means halfway around would be pi. So that's what this is asking me. If I go halfway around, if I go from 0 to pi, what angle is formed? And it is a straight angle. So find the radian measure of the central angle of the circle radius 1 meter. The arc is 1500 centimeters. So this is a little tricky. It goes from centimeters to meters. So I want to get them in the same measurement. So I'm going to do King Henry died by, this is my base, drinking chocolate milk. And then we'll see what happens there. So I'm going from meters, and this is decameters, and this is centimeters. So let's see, I go from meters to centimeters. If I go from centimeters to meters, I move it left 2 units. So that's going to be 15 meters. And now I have the same measurement. So the radian measurement of the central angle. So it wants me to find the radian measure of the central angle. So here's how the move is. The formula is S equals R theta, where theta is in radians, and we need the radius, so it gives us the radius of 1 meter. We don't know what theta is, that's what we're looking for, but it says the arc length, and the arc length is S. It tells us S equals 15 meters, so 15 equals 1 theta. So we divide both sides by 1, and that's easy enough. My answer is just going to be 15. Convert the angle in degrees to radians. So all I need to do is take the negative 31 degrees and multiply it by pi over 180. And we can use the calculator for this move. So we'll just do negative 31 times pi divided by 180. It'll crank it out for us. Negative 31 pi over 140, but it wants us to round it. That's an indicator that we're going to have to hit the SD button. So we hit SD, and there it is, negative 54.1. They just want us to round it to negative 54. They want us to draw an angle and state what quadrant it lies in. So it's negative 7 pi over 6. So I'm going to draw a quick unit circle. I'm going to divvy it up into 6. So there's 30 degrees, 60 degrees, 90 degrees. 90 plus 30 is 120, 150, 180. So that's going to give me 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. 7 pi over 6 would land me here. But they want me to do it in the negative direction. So I'm going to have to go backwards. I'm going to start here and go in the negative direction. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. And that would be choice C. And notice, that's in quadrant 1, 2, and it's in quadrant 2, not quadrant 3, and not quadrant 4. It's in quadrant 2. So it's negative 7 pi over 6 is this picture, and it's in quadrant 2. Now we're looking for 7 pi over 3. That one's a little bit trickier because we have to simplify. So again, I'm going to draw a real quick unit circle. This time I'm going to divide the top as 180 into thirds. So that would be 60 degrees. 60 plus 60 would be 120. 120 plus 60 would be 180. 180 plus 60, let me figure that one out. 180 plus 160 would be 340. So 340 would be 180 plus 60. 180 plus 60 is 240. 240 would place me over here. Plus 60 would place me at 300. Plus 60 would place me at 360. So this is going to be 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3 would place me right there. So let's see which one that lands me on. I know it's in quadrant 1, and it would be choice A. It would be choice A. That's the only one that lands me in quadrant 1. 31 pi over 8, less than 2 pi. So I'm going to take that, and I'm going to subtract 2 pi from it and see what that brings me down to. And notice 15 pi over 8 is less than 16 pi over 8. And 16 pi over 8, that's 2 pi. So let's see, I'm going to do 31 pi over 8. 31 pi over 8 minus 2 pi. And there it is, 15 pi over 8. It gives me the answer quite rapidly. Find the length of the arc, so that's an S equals R theta problem. It gives me a central angle is 260 degrees, R is 13 feet. So the trick is S equals R theta, but I need theta to be in radians. So the 13 times 260 pi over 180 should break it down pretty quickly. So I'm going to type that into the calculator. 13 times 260 pi divided by 180. 13 times 260 pi over 180. 169 pi over 9. It breaks it down pretty rapidly using the technology. Number 8. I kind of like these now. They used to be a problem for me. Angular speed in radians, so 13 revolutions per second. All you do is 13 times 2 pi, and that's it. That's going to give you 26 pi radians. A clock problem. So from 12 o'clock to 5 o'clock it reads. The hand of the clock is 11 inches, so that's going to give me the radius is 11 inches. So it goes from 12 o'clock, that's to 3 o'clock, that's to 6 o'clock, so 5 o'clock. Now I like to break this up into 30-degree increments. So this is 30 degrees, 60 degrees, 90 degrees. 90 plus 20 is 130. 150 degrees in the negative angle here, but that's okay. So they want to know how many radians it moves. And don't forget the radius is 11. So I'm going to do 11, s equals r theta. S equals r theta. My radius is 11, so 11 times 150 pi over 180. And that'll break down nicely in the calculator. 11 times 150 pi over 180. And notice, boom, 55 pi over 6. It squeezes it out quite nicely. Angular speed. Point on a planet is pi over 14 radians per hour. They want to equate. The equator lies on a circle of a radius of approximately 8,000 miles. Find the linear velocity in miles per hour. Since it already tells us it's going in radians per hour, we're going to use S equals r theta. And this is nice. Our radius is 8,000 miles. It tells us that. And then it tells us our planet is moving at pi over 14 miles per hour. That's our theta. So all we have to do is a calculator key of 8,000 times pi over 14. And notice, when we type that into the calculator, we get this nice pi answer, but we change it to decimal. We hit the SD button. And it breaks it down to the nearest mile is 1,795 miles per hour is how fast that planet is moving. Water wheel problem has a radius of 19 feet. It's rotating at 5 revolutions per minute. That's the information. Find the linear speed in feet per minute. In this problem, we have to know that each revolution, if it says the word revolutions, that means 2 pi. There's 1 revolution around. So it's a simple calculator key in 19 times 5 times 2 pi. And that'll give me the linear speed in feet per minute. So let's type it in. 5 times 2 pi times 19. It originally gives me 190 pi. But if I hit SD, it gives me 597 feet per minute. It breaks it down again quite rapidly. We're asked to find all 6 on a unit circle. Find the values of the functions at the point where it's negative 4/5, comma, negative 3/5. And it tells me where that is right there. So that coordinate is negative 4/5, negative 3/5 on a unit circle. So my triangle would look like that. I'm going to make a bigger version of that triangle for us. And that would look like this. And this is my angle theta. And I go left negative 4/5 or negative 0.8. And I go down negative 6/5. I'm sorry, negative 3/5, which is negative 0.6. And I can find this side here by doing the Pythagorean theorem. 0.6 squared plus 0.8 squared. Again, I just type that into the calculator. 0.6 squared plus 0.8 squared. I kind of know this one's going to be 1, so the radius is 1. That's nice. So the hypotenuse is 1. Now I can find all 6 trig functions, trig identities. It has this type them in quite nicely. So sine is actually going to be, I have a cosine value and a sine value. The sine is right there, negative 3/5. The cosine is right there, negative 4/5. To find the tangent, you could do opposite over adjacent, negative 0.6 over 0.8. Or just 0.6 divided by 0.8. And that gives me 3/4. There's another way to do it. You can just take the top, the 3, and put it over the top of that one, the 4. 3 over 4. Now the reciprocal functions, because this is negative 3/5, the reciprocal cosecant lines up with sine. That's just going to be negative 5/3. Negative 4/5 changes to negative 5/4, and 3/4 changes to 4/3. It's key, though. You have to get these correct in order to get these correct. Number 13 is a unit circle problem, but they ask us to evaluate cosine of pi over 2. We don't have to use the unit circle. We just have to make sure we're in radian mode. So I'm going to hit shift, setup, or shift mode 4. And that puts me in radian mode when I'm dealing with radians. So it wants me to find cosine of pi over 2. So I'm going to type in cosine of pi over 2. And here it comes. That is 0. Pretty nice, pretty nice. 14 is another calculator key in. It wants me to find both tangent of 5 pi over 3 and tangent of negative 5 pi over 3. So once again, I'm already in radian mode. I'm going to keep it there. I'm just going to type in tangent of 5 pi over 3. So I hit the tangent button. I'm going to hit my fraction button. 5 pi, down arrow, 3. And that would give me negative root 3 is my answer. So negative root 3 is the answer to that. And then to find the tangent of negative 5 pi over 3, I'm just going to back arrow into my original question and make it a negative out in front. Enter, and that would give me positive root 3. So pretty quick calculator team. All right, for this one, number 15, they give me a Pythagorean identity, sine squared plus cosine squared equals 1. Let's be careful, we're going to need that later on, that little bit of information. That's nice to know. And they tell me that sine equals root 2 over 4, and they give me this identity. So I'm going to put in root 2 over 4 in for sine. Now, what that's going to do is I have to square that, plus cosine squared, t equals 1, and I'm going to subtract that from both sides. So that's going to give me cosine squared t equals 1 minus the square root of 2 over 4 squared. I think I can type that into the calculator. I'm going to type the whole thing into the calculator. Let's see here. 1 minus, parentheses, fraction bar, square root of 2, down arrow, 4, right arrow, close parentheses squared, 7/8. So 1 minus that value equals 7/8. So cosine squared t equals 7/8. But they just want me to find cosine. They don't want me to find cosine t. They just want me to find plain old cosine. So what I need to do is square root both sides. So I'm going to square root my answer. So So while it's still chilling, I hit square root, and I type in answer, and hit enter, and root 14 over 4. And notice, that's my answer. Root 14 over 4. It worked out pretty nicely using the calculator. This one says, do not use a calculator, but notice, it says sine squared plus an item plus cosine squared of an item. That's just going to equal 1. That's the previous identity that we used on the last problem. If you'll notice, they said sine squared of anything plus cosine squared of the same thing will equal 1. So that was a nice gimme, basically. Number 17, another unit circle problem. They tell me not to use the calculator, but I think I'm going to disobey that and go ahead and just type in sine of 2 pi into the calculator. So I'm in radian mode already. Sine of 2 shift pi. And let's see what it gives me. It gives me just 0. And notice, that's my answer. Then it wants me to find sine of 6 pi. So I'm just going to back arrow and change that 2 into a 6. And that's 0 also. Now it says use a calculator. Again, I am in radian mode. I want to keep it in radian mode until the degree shows up. So I'm just going to type in cosine of 7 pi over 17. This one's not on the unit circle, so the answer is going to give me a really crazy decimal. Be careful. Type it in accurately. 0.27366. So it wants me to round it to 4 decimal places. So there's the 4th place, and that there is 5 or above. So I have to give this a shove. So it's going to be 0.2737. Round it nice. Be careful. This is a substitution problem. We want to write it in terms of A, B, and C. So not that big of a deal. It says tangent t equals c. So it gives me tangent of negative t. And what we have to remember are what's called the even odd function. So sine of something negative, that's going to equal negative sine of that item. Cosine of something negative, that kicks it out as just cosine of that same item. It doesn't turn it negative. Tangent is sine over cosine. Because it has the cosine in it, that comes out positive. But the sine comes out negative. So tangent of a negative number is going to give me negative 7 tan t minus tan t. And it tells me that tan t equals c. So that's going to give me a c value here. So it's negative 7c minus c. And that's just going to equal, combine my terms, negative 8c. This is the trick to know these two. So I'm going to figure out what this is now. So it's going to be negative 17 plus 8 units. I think it's going to be negative 9. This is actually 0, though. This isn't negative 17. This is actually y equals 0. This is the x-axis. So this is going to be 8. And then 8 plus 9 is going to give me 17. And then 17 plus 9 is going to give me 26 feet. So the highest this thing goes is 26 feet. So at 9 a.m. it's at 26 feet. At 6 a.m. it's at 17 feet. At 12 noon it's at 17 feet. At 3 p.m. it's at 8 feet. And these are the questions it asks us. Notice, it'll say the height of the water at 6 a.m., and we use our graph, is 17 feet. And then it asks the height of the water at 9 a.m. At 9 a.m. The height of the water at 9 a.m. is 26 feet. Then the height of the water at noon is back to 17 feet. The height of the water at 6 p.m. is 17 feet. The height of the water at midnight, ooh, that's a tough one. I have to keep going. I think it's going to cycle 12 hours from there. It's going to be back to there. So it's going to be back at 17 feet. And then the height of the water at 3 a.m. Oh, I don't have a 3 a.m. here. I have a 3 p.m. I'm going to go back another 3 hours backwards. So that would give me 3 a.m. And I'm going to say it's going to be at 8 feet. Then when is low tide and when is high tide? So low tide is at 3 p.m. And also at 3 a.m. High tide is at 9 a.m. And then I'd have to add another 3 hours. 6 p.m. that would be 9 p.m. So high tide would be at 9 a.m. and 9 p.m. And all those answers match up. Right triangle trig. First thing I want to do is I'm going to find out what the hypotenuse is. So I'm just going to do the square root of 15 squared plus 8 squared. That's basically the Pythagorean theorem. So the square root of 15 squared plus 8 squared, 17. So now I can solve every trig ratio. So sine of theta equals cosine theta equals tangent theta equals cosecant. I know it's a bother. Goes with sine. Theta equals a fraction. Secant theta equals a fraction. And then cotangent theta equals a fraction. SOHCAHTOA. You want to write this down as soon as you get into the testing center. SOHCAHTOA. Some old hippie caught another hippie tripping on apples. So here we go. Sine is opposite over hypotenuse. So opposite theta is 8. The hypotenuse is 17. Cosine is adjacent over hypotenuse. The adjacent side is 15, and the hypotenuse is 17. Tangent theta is opposite over adjacent. Opposite is 8 over 15. And then the reciprocal functions are just that. You just flip them. 17 over 8, 17 over 15, 15 over 8. Not that troublesome.